Well, the way food is growing is changing, whether it's from labor constraints or increased water regulations out west. It's a catalyst creating that change. Here at the University of Minnesota, researchers are experimenting with new technology to help growers use less water and produce more food, but all indoors. And it's opening a new field of opportunity.
Bright lights, rows of kale, lettuce, and dwarf tomatoes that fill the room. There's something missing in most of this greenhouse, and that's soil.
One of the major factors that we have going on is hydroponics here. Hydroponics is literally water working. In Greek, that's what it means, working with water. And so a lot of our plants here, if I were to pull these out, there is not a soil substrate in there. It is pretty much just roots hanging out in water.
Assistant Professor Nate Eylands focuses on controlled environment agriculture, or CEA. Here, plants grow in a hydroponic system that recirculates water, sloping gently to drain and pump back again. A closed-loop system that saves both water and nutrients.
What is the benefit of growing these plants in water versus soil?
Right. So having this recirculating system is probably that primary benefit. We are able to use about 9 to 10% of the water that you would for growing these per kilogram basis, per biomass basis. This 9 to 10% of that water that you'd use out in the field.
Just because it's recirculating?
Just because it's recirculating. We're not having any runoff. Any of our nutrients aren't leaching out into the environment, into our waterways. So by recirculating, we're only providing, and the plants are only taking what they need at that very moment.
But saving water is just the start. Eylands' team is experimenting with quantum dots. Those are microscopic particles that transform light to make plants grow faster.
Quantum dots are little nanoparticles, and they absorb photons of light and change that photon into a different photon. So say you have blue light coming in, it might be red light coming out of it. So what we're doing is taking a liquid quantum dot and we're spraying it on some of these plants. You can't tell which ones of them have it. And then on the leaf surface, they are absorbing that photon, say a blue photon, and converting it to a red photon. And that might speed up the process of photosynthesis at different stages of the plant growth.
By altering the light spectrum, researchers hope to speed the flowering on these plants, which will then boost yields and ultimately make indoor production more efficient.
What we're trying to find out is, can we get to an earlier flowering time? Can we get more fruit out of an individual plant? Can we speed up the vegetative cycle? Can we do any of these phenology benefits that help growers out in an economical way that leads to profitability?
His larger mission is clear: make controlled environment agriculture more profitable for commercial growers and squash the misconception that growing produce indoors doesn't pencil.
Ultimately, it's about profitability. We run into a problem of profitability. The economic model always has to work out. We pay for lights, we pay for infrastructure, all this equipment around us. That capital cost is pretty expensive. So what I want to see is more productivity out of these plants so that when we look at production costs, overall they come down for growers.
From light-bending nanoparticles to water-saving hydroponics, the work here at the University of Minnesota could reshape how America's produce is grown and take profitability for those growers to new heights.
Eylands told me right now it's cheaper to grow produce in the field, but it's this type of work that could possibly change that in the future. Well, when we come back, tensions between the U.S. and China, we've talked about it. They heated up this week. Could that market be gone for good? Our marketing discussion happens from right here at the University of Minnesota next.
You're watching U.S. Farm Report. Trusted, timely, tradition.